Today, I'm going to show you how easy it is to get started with our HP Omnicept plugin in your game engine. Let's start at the developers portal, hp.io/omnicept. The landing page tells us we need to do a few things to get started. Download the SDK, sign up on the console, get our app credentials, and then create an Omnicept-enabled app in Unity or Unreal. While the full Omnicept SDK downloads, let's begin by signing up on the console. You will need to have an HP ID to sign up on the console. The console is needed to get your Omnicept credentials and to begin your trial. The trial allows for full access to the Omnicept SDK for 30 days. Full access means access to the sensor data as well as the inference engine, which contains goodies like cognitive load. After 30 days, your trial is going to transfer into the core mode, which only allows access to raw sensor data. If you want to keep using all the features, you can convert your trial or core into academic, developer, or enterprise licenses. You can learn more about these licensing models on hp.io/omnicept. We'll populate the company information, and now we're logged into the developer's console. We'll create an application here. This application will contain the credentials needed in the game engine. Okay, now let's make sure everything is working inside of Unity. Let's create a new project called Omnicept Test. Let's import the Omnicept package by going to Assets, Import Package, Custom Package, and then navigating to the Omnicept plugin. So C, Program Files, HP Omnicept SDK, Unity, and then double-click on the Glia Unity package. We'll import everything that is in this package. And then we'll go to Glia at the top, Configure. We'll need to add our app key and our client ID from the developer console. This will connect our Omnicept app to our Omnicept license. Now that should be saved. So let's test that everything's working. We'll add the HP Glia prefab to the scene. This is needed to access the Omnicept sensor and inference engine data. I'm going to create an empty game object and name it debug. And I'll add the debug print messages script to this object. Okay, keep everything checked. Going back to the HP Glia prefab, I want to add to the on cognitive load behavior. I'll add my debug print message, my debug game object, and I will call the debug print messages and the cognitive load handler. Okay, now I'm going to click play and see if I am connected to Omnicept or Glia, in this case, the same thing. I'm connected to Glia, great. Now I'm going to send cognitive load messages via the Omnicept simulator. This comes with the SDK. It is a hardware simulator, so in case you don't have hardware, you can test your connections via this. So I'm going to send simulator events, and I could see that I am getting the simulator events inside of Unity. As I change the values in the simulator, it is changing in Unity. So that's great. That is set up. I will stop sending messages. That works too. The next thing I would test is I would put on a Omnicept Edition headset, make sure the simulator is closed and not sending any events. And so I could see that if events are being sent from my headset. Note that it takes about 12 seconds for the cognitive load inference engine to send cognitive load data from the headset to your application. So this is a good time to introduce your user to the scene or to the experience. Okay, let's make sure everything is working in Unreal. Let's add the plugin to our Unreal project. I'm going to add the Omnicept plugin to the whole engine, but I could just add it to a project that I'm working on. I'm going to navigate to the HP Omnicept SDK folder and find my version of Unreal, so I'm using 4.26, copy this HP Glia folder, and now navigate to my Unreal Engine folder, Engine Plugins, and paste that HP Glia plugin. going to create a new project and call it Omnicept Test. Once Unreal loads, I'm going to go to the plugins page and find HP. I'm going to enable the HP Glia framework. It's going to prompt me that it wants to restart. I will restart. HP Glia is enabled. Great. I'm going to open the level blueprint. I'm going to connect to Glia Async. This has connection settings. So I'm going to add a connection settings module. I'm going to get the client ID and access key from the developer's console. The license mode is trial, so this is correct. And I will connect this to my connection settings. Next, I will connect to Glia delegates. I will bind event to connection to Glia delegates from get Glia delegates. And then from this, I'm going to create a custom event called onConnection to print out the connection result. I also want to print out the cognitive load data. This is a good test to make sure that everything in the Omnicept connection chain is working correctly. Cognitive load is a premium feature only available with a trial or fully licensed connection. So I bind Glia delegates to cognitive load delegates and create a custom event on cognitive load. Cognitive load provides both the cognitive load and the standard deviation. So I'm going to break cognitive load so I can just get the cognitive load data, print it out. Okay, I'm going to hit play. I see success. This means that our Omnicept credentials are correct. Next thing I want to do is run the hardware simulator that comes with the SDK. I could send cognitive load events from the hardware simulator, and I see that in Unreal it is matching what I am putting in the hardware simulator. So next thing I would do would be to close the simulator and put on my headset to make sure that my headset is also sending cognitive load events. Keep in mind that it takes about 12 seconds from when you put on the headset for the first time for the inference engine to learn your cognitive load and to send cognitive load to Unreal. Okay, so the last thing I'm going to do is to add an event end play and disconnect from Glia